For today's lesson, we're going to be looking at the mean absolute deviation, and you will hear to that referred as the MAD. The mean absolute deviation is another measure of variation, so when we're using this measure, it's another way of looking how widespread the data is. The mean absolute deviation of a data set is the average distance of the data values from the mean of the data. So we're going to look at the example with a data set of 1, 3, 7, and 9. The first thing we would do is find the mean. If we add up all these numbers, 9 and 1 is 10, 3 and 7 is 10, so 10 and 10 gives us 20. 20 divided by 4 is 5, which means the mean of this data set is 5. We're going to use this number line to illustrate what the mean absolute deviation shows and what it is. If you look on the number line, you'll see in green we have our mean plotted, and then we have our 4 points of data that were given in the data set, 1, 3, 7, and 9. Now the absolute deviation is how far away each unit is from the mean. So if you look at 7, 7 is 2 units from the mean. 3 is also 2 units away from the mean. Then we have 9, which is 4 units from the mean. And we have 1, which is also 4 units away from the mean. So this is the absolute deviation of each number in the data set from the mean. 1 is 4 away, 3 is 2 away, 7 is 2 away, and 9 is 4 away. Think of this as the same as your absolute values. You'll notice up here there are no negative values. An absolute value is the distance a number is from 0. Your absolute deviation is how far away each data point is from the mean in this situation. The next thing we're going to do to find our mean absolute deviation is take the mean of these 4 numbers that we just found. So the 4 numbers are the 4 distances that each data piece is from the mean. We will find the average of those. So we're going to add together 4, 4, 2, and 2. And because there are 4 pieces of data, we will divide that by 4. 4 and 4 is 8, plus 2 is 10, plus 2 more gives us 12. So we're left with 12 divided by 4, which gives us 3. This 3 represents our MAD, or our mean absolute deviation. What this is saying is that on average, each piece of data is 3 units away from the mean. The smaller the mean absolute deviation, the closer the data set is going to be together. The bigger the mean absolute deviation, the more widespread your data is going to be. So again, this is just another way of looking at variation or how widespread data is. The last example was kind of a breakdown of what the mean absolute deviation is. In this example, we're going to give a step-by-step breakdown of how to find the mean absolute deviation. So we're given a table of data here of the scores of 10 people that were playing darts. Our first step to finding the MAD would be to find the mean score. So you want to add up all pieces of data and then divide by 10. When adding up these numbers, I'm going to take all the tens places first, and then I'll take the ones just to show it quickly. We have a 40 and a 60, that's 100. We have a 30 and a 70, that's 200. Another 60 and 40, that puts us at 300. 250s puts us at another 100, so we're at 400. And then 50 and 40, that gives us 490 for our tens. When adding up the ones, I'm going to try to make pairs of 10 again to do the same. We have a 1 and a 9, so that gives us 10. We have a 3 and a 7, that puts us at 20. 25, 29, 38, and 40. So we are left with 40 for our ones place. We will divide all of this by 10. 490 and 40 gives us 530. 530 divided by 10. We can cancel out the zeros, which is 53 divided by 1. So our mean is 53. Step 2 is to find the distance or deviation of each value from the mean. So I created a table to help keep the data organized. And what we do to find the distance is we take our mean value and our data item and we subtract them. The absolute deviation is always going to be a positive, so we take the bigger number minus the smaller number to get our distance from the mean. So for our first piece of data, we have 54 minus 53, which gives us 1. The next section would be 53 minus 40. That gives us 7. 69 minus 53 is 16. 53 minus 49 is 4. 73 minus 53, that gives us 20. 53 minus 42 is 11. 53 minus 35 is 18. 60 minus 53 is 7. 53 minus 51 is 2. And 57 minus 53 is 4. Our third step is to find the sum of the distances. When we add up all of the distances, that gives us a sum of 96. After we find the sum of our distances, we take that sum and divide it by the total number of data values, and that will give us our mean absolute deviation. So our sum was 96. We had 10 data values. When we divide 96 by 10, that leaves us with 9 6/10, meaning our mean absolute deviation, or our MAD, is equal to 9 6/10. And those would be the 4 steps that you use to find your mean absolute deviation.